Hello everyone, this is Dr. Suganya working as an associate professor in Department of Computer Science with Cybersecurity at Dr. SNS Rajalakshmi College of Arts and Science. So in this video I am going to explain about the topic key management in the course Applied Cryptography. Let us now go inside the video. So when we speak about the key management in cryptography, actually before going inside the video, we should know what is a key management. So key management means handling the cryptographic keys in a secure way throughout their entire life cycle. So this life cycle includes how we are generating the keys, storing them safely, distributing them to users, using them properly, rotating, and finally destroying the key also. So we should be very cautious that whenever a key is open, it should also be deleted when it is not used. So basically it is about managing the keys from the starting process till the end of the thing, but it should be done securely. So the next slide is about the objectives of key management. So actually there are four main objectives of the key management: confidentiality, access control, viability, and secure communications. So when we speak about the confidentiality, the keys should be kept secret and it should not be exposed to the unauthorized users unnecessarily. And when we go for the access control, so it is about accessing the keys actually. So only the authorized people or the systems should use the keys, not others or all should not use that keys. So next is the availability. So availability ensures the keys that are accessible when required by legitimate users and the systems. That is, the keys should be available when needed and that should not be lost or inaccessible whenever needed. And finally, the secure communication. So the keys help in encrypting the data so that the communication will be always safe. So supporting the encrypted channels and protecting the data in transmit between the authorized parties is called as the securing communications. The next slide is about the key generations and distributions. So now let us see how actually the keys are created and shared. So key generation, so keys must be generated using the strong random number generators. So this ensures that keys are unpredictable and hard to guess also. For example, we can use the AES algorithms and RSA algorithms like 256, 2048. Likewise, the numbers can be opted. Next is the key distributions. So after generating the keys must be securely sent to the users, and this can be done only by securing the channels, public key cryptography, key distribution centers, etc. etc. So for example, we can offer the SSL, TLS using the public keys in order to exchange the symmetric keys securely. So the next slide is about the key storage and usage. Once the keys are created, they must be stored safely. So the key storage means the keys should not be stored in a plain text. Actually, they should be stored in a cryptographic text only. They are stored using the HSM, means hardware security models, TPM, trusted platform modules, and encrypted storage. So after the key storage, we have to move for the key usage. That is, the key should be used only for the particular or specific purpose, like encrypting the data, decrypting the data, creating the digital signatures, etc. etc. Also, the keys can access and it should be controlled very strictly whenever it is not used. So next one is the key rotation and revocation. So key rotations, keys should be changed regularly in order to reduce the risk. For example, we have to exchange the keys every 90 days or some certain days we have to fix and we have to change the keys. So key revocation, if a key is compromised or expired, it should be immediately invalidated. This is managed using CRL, that is certificate revocation lists, or OCSP, that is online certificate status protocol. So the next slide is about the key backup, recovery, and destruction. So the final stage of the key life cycle ensures the business continuity. So in order to prevent the unauthorized access, in order to prevent the keys. These are the final stages in the key life cycle actually. The key backup. Keys should be backed up securely in order to avoid the data loss. Next is the key recovery. So if keys are lost, there should be a secure way to recover them. So, and key destruction. So when keys are no longer needed, they should be permanently deleted so that the attackers cannot be able to recover them. So this slide is about the key management techniques. So there are different ways to manage the keys, like symmetric key management, asymmetric key management, and much more. So this, whenever we speak about the symmetric key management, the same key is used for encryption and decryption also. So in asymmetric key, it is an opposite way, that is only one key is used for the encryption, another one key is used for the decryption. So PKI, that is public key infrastructures, the system that manages the digital certificates and keys. It also helps in building the trust between the users. So this is the pictorial representation of the public key infrastructure, that is PKI. It involves the certificate authorities, trust model, digital certificates, etc. So these are some of the common key management problems we face, that is when we use the weak or reused keys, poor random generations, insecure storage, and lack of rotations. So finally we came for the conclusion of this key management, that is when we even a strong algorithms will fail if keys are not properly handled. So poor key management means it prevents the data breaches, it protects the sensitive informations, it ensures the secure communication, and helps to meet the security standards. So finally, I conclude this video by saying that key management is the backbone of cryptography. If the keys are secure, and the whole system will be secure. Thank you so much. Hope this video is useful for you.